Okay folks, I'm going to try to make this as painless as possible today. We are going to be learning about solutions, suspensions, and colloids. As you can see in the image above, the main difference between all three is how large the particles are. So the smallest particles, that's going to make up a solution. As the particles get larger, you're going to reach a colloid, and then finally the largest possible combination of particles is going to create a suspension. Remember, these are all going to be found these are all types of mixtures, I should say. So in a solution, it's a mixture that appears to be just one substance, but it's actually comprised of two or more substances that are just evenly distributed amongst each other. This is also called a homologous mixture, and if you look in the picture there to the right, it looks as if it's just one substance, but really it is a mixture of two or more substances that simply look like one object or one single substance. So in a solution, you're going to have two parts. You're going to have a solute and you're going to have a solvent. The solute is a substance that is dissolved. The solvent is the substance that's doing the dissolving. So in the case of salt water, for example, the salt would be the solute and the solvent would actually be the water. Now there is a special term I want you to know, and that's called alloy. And believe it or not, metals or nonmetals can actually dissolve in metals. And we'll see an example of this on the next page. So some examples of solutions include salt water, as I explained before, and again, it's salt being dissolved in the water. Then there's dry air, which is oxygen and nitrogen. Soft drinks like sodas or colas, which are carbon dioxide and water. Antifreeze, which is alcohol and water. And then there's an alloy, brass, which is zinc and copper. And that brass trumpet there on the right is an example of an alloy. The particles in a solution are extremely small, and for that reason they never settle out, they can't be filtered, and they can't even scatter light. So if you were to shine a light through a solution, it wouldn't scatter back. You wouldn't see the light beam. Solution is also, or when we're looking at solutions, we also look at the concentration of the solute in the solvent. So as you can see in the image below, if it doesn't have very much solute, it's called a diluted concentration. The more solute you add, however, it becomes more and more concentrated. What we're looking at when we're talking about concentration is solubility. So the amount of solute that's needed to make a saturated solution that's using a given amount of a solvent at a certain temperature. So as you can see in the picture on the right there, we have the solute, salt, and we have the solvent, water. We end up making a nice saturated brine or saltwater solution, but then you have excess salt. So I know that it's reached its maximum solubility. That saturated brine can no longer hold any more salt. It is full to its capacity. So there are some ways that we can increase the rate that the solute dissolves in a solvent, and I'm sure you've done this before in the kitchen. For example, mixing definitely helps increase the rate that the solute dissolves. Heating or crushing, these are all good ways to get something dissolved really quickly. Okay, we're now moving on to the next type of mixture, which is a suspension. This is a mixture in which the particles are dispersed throughout a liquid, but they're so large that they actually settle out. These particles are insoluble, meaning that they won't dissolve, and a suspension is also known as a heterogeneous mixture because it looks like two or more things combined together. You can definitely see the different components in a suspension. Here are some examples of suspension. Muddy water, Italian salad dressing, and if you look to the right there, a snow globe is actually an example of a suspension because the snowflakes settle out. So again, those particles are going to scatter light. So if I were to shine a light through that snow globe, the particles would actually reflect the light back. The particles will settle out, which is why you have to keep shaking up your Italian salad dressing. And it can be separated with a filter. If I had a filter small enough, I could actually filter out all those snowflakes in the snow globe, which would defeat the purpose of a snow globe. A colloid is the third type of mixture that we're going to talk about, and the colloid is kind of a mixture or a combination between the solution and the suspension. So in a colloid, the mixture is a mixture in which the particles are dispersed throughout, but they're not heavy enough to settle out. The particles are relatively small, and some examples include milk, mayonnaise, stick deodorant, Jello, whipped cream, all of those are examples of colloids. So in a colloid, the particles are actually going to scatter light. The example there on the right, that's fog. It looks like snow, but it's actually supposed to be fog. And as you can see, the light beams are scattering light, and that is an example of a colloid. The particles cannot be separated by a filter because they're still too small and they can actually fall through the filter holes. That does it from me in talking about different types of mixtures. If you have any questions in class, please feel free to let me know. I will expect that you will have watched this video at least once, but if you have questions, make sure to ask before you have your next test. Best of luck. Thanks.